Hi, everyone. I'm Valentina Rozanova. I've been the one flooding your inbox with emails the last couple of days. Just giving you a quick introduction here. I'm going to hand it off in a few minutes to my colleague, Newman Kershid. He's our outreach account manager with the New Jersey Clean Energy Program. He'll provide you with a brief, about 10-minute presentation on our new construction offerings and latest program updates and happenings in case any of you haven't been plugged in as much as you'd have liked to be. So he'll give you some of that information, and then we'll transition to Christina LaPearl. She'll be providing you with the core of our presentation today, the P4P new construction, quality control, common issues and tips. So with that, I won't take up any more time, and I'll go ahead and stop sharing my screen, and I will hand it over to Newman.
All right, so good afternoon, everyone. My name is Newman Kershid, and on behalf of New Jersey Clean Energy Program, I want to welcome you all to today's Pay for Performance training webinar. So I represent New Jersey Clean Energy Program as a commercial and industrial outreach account manager, and I'm happy to be part of this dedicated team that helps delivers all these energy savings to energy users in New Jersey through our program. So today I will present a brief high-level overview of our program portfolio and introduce these programs that can be utilized for new construction projects specifically. So starting with a bit of background, as all of you probably already know, New Jersey Clean Energy Program is administered by the New Jersey Board of Public Utilities. Funding for New Jersey Clean Energy Program is provided through a societal benefit charge that ratepayers will find on their investor-owned utility bills. So along with helping residents and businesses save money, these incentive programs have a positive impact on the environment, helping to lower emission, helping other states meet its goal of 100% clean energy by 2050, as published in New Jersey's Energy Master Plan. So our energy conservation and energy efficiency programs help limit the amount of energy consumed, resulting in additional cost savings, and help build a more sustainable energy future for New Jersey. So for added energy resiliency, we also offer specific programs related to distributed energy resources, such as combined heat and power and fuel cell technologies. And all of our energy savings and efficiency programs act as a first step, allowing for better integration of renewable energy technologies like wind and solar. So that's where we say that energy efficiency is the logical first step to take. Right, so the Clean Energy Act of 2018, it really sets the stage for the creation of specific energy goals as outlined in the Energy Master Plan, and it provides guidance for Clean Energy Program. So the Energy Master Plan serves as a roadmap to achieve New Jersey's ambitious energy goals, and this document is closely monitored by all industries in New Jersey, helping identify how they can help support New Jersey energy targets and help achieve them as a state. So some of these goals include 100% clean energy by 2050, a large reduction in carbon emissions, and to ultimately promote a stronger and fairer New Jersey. This last element addresses the need for economic, social, and environmental equity through energy conservation and resiliency. So now I'll describe some of recent highlights of our programs and describe our results in a more tangible way. These next couple of slides will reflect the performance of New Jersey Clean Energy Program for the last fiscal year. And we thank all of you for your contribution, as this is a direct result of the work and effort of our participating contractors. Right, so in fiscal year 2020, we processed over 140,000 applications, resulting in nearly $140 million in paid incentives. So these energy savings were delivered and realized through efficiencies in electricity, gas, and oil consumption, as well as other forms of energy generation. Having a background in environmental science and sustainability, this is one of my favorite slides because it shows results in a more tangible way. The amount of carbon dioxide emissions saved from our programs during last fiscal year equates to 159,000 cars removed from our roadways and over 12 million trees planted. The big takeaway here is that these amount of GHG eliminated has an obvious impact in furthering a more sustainable energy future and move along the Energy Master Plan. So how we achieve all these results is through a wide range of programs offered within our portfolio. And as you can see, we have 5 different buckets of programs. In addition to our suite of commercial, industrial, and residential incentive programs, we also have programs related to renewable energy and also specialized energy efficiency programs for new initiatives, research, and planning grants. Our programs will be impacted by the upcoming transition mandated by the Clean Energy Act of 2018. So all of the energy efficiency programs are currently being managed by New Jersey Clean Energy Program. However, between April and July, some of these programs will begin to be run by local utilities. And I'll get to that, but as it stands, all of these programs that you see today are still accepting applications till June 30th, which is the end of this fiscal year. And whatever gets approved by then will be seen through the end. So once the transition begins, a portion of both CNI and residential energy efficiency programs are transitioning to be managed by investor-owned utility companies, as mandated by the Clean Energy Act. So these programs are mainly on the existing building end, and anything else is staying with the Clean Energy Program. So as you can see here, both CNI and residential existing building program efficient products are transitioning to the management of the local utilities, while the rest of the program will stay with New Jersey Clean Energy Program. The programs that provide incentives for new construction projects will remain with this program. So that's where it's important to know that you would still submit an application with us for anything new construction. So this transition will ultimately serve as a benefit to end users and customers as the availability of on-bill financing will increase. There are long-term benefits to these transition post June 30th or July 1st. So when advising potential users of our incentive programs, we usually begin with something we call a triage process. This is where we determine their initial eligibility based on their utility bill and the size of buildings for a new construction project. This is especially important for P4P because of the requirement of having 50,000 square feet or more planned condition space. Whereas Smart Start or Single Major Rebate Program is our catch-all program for single energy consuming equipment like HVAC units or lighting. So as part of our initial triage, we also determine eligibility for residential program, especially in the case of multifamily new construction projects. That's where it can get tricky that you could either do P4P new construction, or you can also do residential new construction if that multifamily is pursuing Energy Star certification. So then we triage that to residential new construction program because that's more suited for that multifamily project. So I'm sure you're all familiar with the Pay for Performance program, but as a reminder, in order for a project to qualify for new construction, P4P, it has to be 50,000 square feet or more planned condition space. Additionally, substantial renovations will also be eligible for P4P. So gut rehab also qualifies, for example, change of use or reconstruction of a vacant structure. So we inform all potential users that because of the approval and verification process, P4P projects may take up to 2 to 3 years. However, the incentive values are significant as they can go up to 70 to 80% of the total project cost. We always like to highlight some success stories. So here is an example of a new construction multifamily high-rise project located in Jersey City. They use P4P program to realize energy savings of almost $200,000, and these energy efficiency measures with the incentives combined resulted in a short payback period of 1.5 years. Another success story, this is one of our newest success stories, and it shows an excellent example of pay for performance projects. So Bellworks in Homeville, they modernized their facility and a conference hall with LED lighting, a heat recovery system, integrated controls, and VFDs to increase the comfort in their spaces and save on annual energy costs, substantial energy costs. As you can see, almost $500,000 in annual energy costs was saved as a result of this project. So incorporating $2 million incentive paid through New Jersey Clean Energy Program, the payback period dropped to roughly 4.5 years. So moving on to our single major rebate program, Smart Start. The Smart Start program is used to cover energy efficiency equipment, upgrades for commercial, industrial, government, buildings, agriculture customers. Anything that does not qualify for P4P, Smart Start rebate is the next best option. So how it works is it's fairly simple. There is a rebate attached to the energy efficient equipment to incentivize installing that. There are two tracks for this program, which are prescriptive measures and custom design measures that I'm going to expand on shortly. Before that, you can find the details on the values of these prescriptive incentives through our website, which are different for each qualifying equipment. For custom measures, the incentives are calculated based on the lesser of the three categories based on energy savings, install costs, or the payback period. So like I said earlier, there are two tracks for this program. The prescriptive track includes a list of energy efficient equipment for lighting, for example. It has to be DLC certified or Energy Star certified. So they tell you how energy efficient equipment is. So prescriptive measures can cover anything from lighting, electric chillers, VFDs, gas heating to food service equipment. And you can find a list of eligible equipment from our website for more detailed information. So if you're installing one of those prescriptive equipment, you can get a rebate through the Smart Start program. Alternatively, you can use the custom route for emerging energy efficient technologies that are not covered under prescriptive measures, but they can still show cost-effective efficiency improvement. Although pre and post inspection are required for custom measures and they must meet codes for retrofit projects. So you cannot just do a custom measure and expect a rebate. It has to be pre-approved by us. So lastly, within the residential portfolio, we have the residential new construction program designed to provide builders and homeowners with a range of participation options. There are three different levels of energy efficiency options for new homes as well as multifamily high-rise program, which requires a 15% increase energy savings above code. Benefits of our residential new construction program include better wall-to-wall comfort and durability, high performance heating and cooling, and a tighter overall building envelope. Additionally, single measure rebates can also be obtained through our residential new construction program. So that summarizes the suite of programs we have for new construction. Again, there are indeed incentive programs suited for any type of project, whether it's new construction, comprehensive, or single major upgrade. And as I mentioned before, I'm here to answer any questions you may have about any of these programs contained within our portfolio. So I'm also happy to give separate presentations to your individual organizations or anyone with an interest in learning more about New Jersey Clean Energy Program. So please take down my information and reach out with any questions. Tina, take it away.
Thank you, Newman. Well, first I'll just introduce myself briefly. I'm Christina LaPearl. I work for Cartman Consulting and part of the review team with TRC that reviews the program submittals for the P4P program. I'm also an energy modeler myself, so I create and submit energy models to not the P4P program, but other incentive programs and also for enterprise green communities, EPA, multifamily high-rise programs like that. Okay, so today we're going to talk about quality control, common issues, and tips. So this is the agenda. We're going to do a short introduction just to set the stage for what we're going to talk about today. We're going to touch on some general quality control concepts that we think would be useful for you to incorporate into your own procedures. Then we're going to do a demo of just a few of the types of quality control checks that we recommend and that as reviewers that we're going to be doing on your submittals. Then we're just going to go over some common issues and tips for all of you. And then we'll end with some questions. I think we're going to stop as well midway, see if there are any questions. All right, so the objectives. So first objective is to understand the resources available to you for conducting quality control. So I'm going to talk about it in a moment, but there is a review manual. And then there's also the compliance form which is actually required to be submitted for P4P projects, but it makes a great tool for completing quality control before submitting the program. The next objective is to describe what is required to be completed in terms of the quality control checks tab, which we'll talk about, and that's located in the compliance form. So there are some minimum requirements that we expect submitters to carry out before submitting to the program. And then last, an objective is for you to understand some common mistakes and some tips for avoiding them. Okay, so let's jump into the introduction. Okay, so for the P4P program, there are two paths for demonstrating performance. We have the ASHRAE BEQ as designed path. In that scenario, you basically follow the proposed design rules of Appendix G, and you create a single, basically more or less as designed model. And the source EUI of that model is used to determine the project performance. So in that case, you've got one model. The other compliance path is the ASHRAE 90.1 2016 Appendix G path. Now, as of right now, that's the most popular path for the program. So that's going to be the focus of today's training. The principles that we discuss, they also apply to BEQ projects. The exception of we're going to be talking about some baseline checks. There are no baseline checks for BEQ projects because there is no baseline. So that's really the main difference. All right, so then because we're going to be focusing on Appendix G, let's just go over the general concept of Appendix G. So with the Appendix G method, you have two models. You've got the baseline design model, which is created using the rules in ASHRAE 90.1 Appendix G. So you have to model certain HVAC systems in the baseline, specific parameters for lighting, for controls, things like that. But the proposed design model is essentially close to, with maybe a few deviations, the as designed or the proposed design model based on the design documents. And there are a few things that need to be held constant between the two models. And they include that you need to use the same simulation tool for both models. The weather file needs to be held constant, and the utility rates. So that's the basic concept behind an Appendix G performance-based submittal. Okay, so when you've got your project that you're creating, there is some required program documentation that needs to be filled out. And I've got the items that are, this is a screenshot of the P4P portal. And the items that are necessary are boxed here in red. Today, we'll be focusing on the ERP tables and the compliance form, which are both required for participation in the P4P new construction program. So those will be the focus of today's training. Like I said, because we're not focusing on BEQ, we're not going to discuss these other pieces of documentation today in detail. All right, so some tools for conducting QC. So as I said before, on the left, we've got the PNNL/DOE ASHRAE compliance form, which the P4P program uses and has a custom version. And then we also have the PNNL/DOE ASHRAE 90.1 Section 11 and Appendix G submittal review manual. So these are both great tools to use for conducting QC on your submissions. In the next slides, I'll go into them in a little more detail. So the compliance form, we went into the compliance form in a lot of detail in the previous training. So I'm just going to touch on the items in this slide. Basically, it's an Excel tool. As I said, there's a custom version for the Pay for Performance program. It provides an easy format to meet the reporting requirements of the program. It helps to, it has automatic lookups to help establish modeling inputs, and it has built-in calculators as well. So it helps to establish the modeling inputs for both baseline and the proposed models. There are some tabs that allow you to import simulation results from the major simulation tools, so that the compliance calculations are pretty automated within the tool. And then lastly, here, and this is the focus of today's training, it includes actually a couple quality control checks related tabs. And this is both to help with your internal QC processes. It also helps with the review process as well. Okay. So as I said before, then we have the review manual. So this is a companion to the compliance form. It supports both Section 11, which isn't allowed for the P4P program, but just for your knowledge, it supports Section 11 and Appendix G projects. We have a link on this slide, so this presentation will be posted on the website for the program, so you can download it, and there are quite a few links within the presentation itself. So you can open up the presentation and you'll have the link right here where you can go and download the review manual on the DOE website. So it includes strategies for prioritizing submittal reviews and also quality control processes. There's a whole list of review checks in the manual, and the list of review checks in the manual are also included in the compliance form on the quality control checks tab. So within the review manual, each check summarizes the relevant sections of 90.1. It provides some tips for seeing if the submittal complies with that check. Steps like where do you locate information within the compliance form to see if you're meeting the check. It includes common mistakes and also some tips for troubleshooting an issue if you do find you have one in your model. Also included in the review manual, which I find really valuable, are simulation reports for common building energy modeling tools that are annotated with tips on performing the specific checks in the review manual. So I know sometimes it can be a little overwhelming. You read a check, okay, check that lighting power, and the compliance form matches the simulation, and you say, well, how do I figure that out easily? Well, these reports in the review manual really help with that process. And we'll talk more about that later. So this is today's focus is on the quality control checks. All right, so this manual was developed for different user groups. I'm not going to go into this in detail, but for rating authorities so that they can come up with review procedures and a review framework. Submittal reviewers like myself, Val, and Chris, and the whole team at TRC for performing reviews of your submittals. And then lastly, for energy modelers, and really to help establish an internal quality control process to really help reduce review iterations and the amount of hours spent on the energy model and on fine-tuning the submission. So today the focus is on energy modelers and design teams. All right, so let's go into the general concepts. All right, so here is a 4-step process for completing a quality control procedure. So step 1. Now, first I want to preface this actually by saying that it can either be the person completing the quality control, it can be someone, a colleague in your organization, a supervisor. It's not necessarily the modeler. So the steps might be a little different depending on who exactly is doing the review. But I'm going to be talking about quality control from both perspectives. So both the energy modeler QCing their own submission, and then also someone who's unfamiliar with the project within your organization doing the QC. So for step one, you're going to check the submittal for completeness. And then if you're not familiar with the project, you need to also develop an understanding of the project as well. That's step one. And there are some tabs in the compliance form that facilitate this process. So there's a submittal checklist, there's a dashboard tab that we'll talk about in a little more detail. There's a general information tab with general information about the project. And there's an energy performance summary, and we'll talk about these in a little more detail later on. Step two, you're going to establish the quality control check scope. So within your organization, do you want to just focus on the really impactful systems? So you can look at where are we seeing the most savings in this project? Okay, so let's focus our quality control on the end uses where we're seeing the most savings. That's what we're going to do. Or you could say, you know what, we found that these QC processes are just really beneficial. They reduce review times. We're going to expand our QC scope to include all end uses and components. So you need to establish that scope. Step three, once you establish the scope and you've identified the checks you're going to perform, you perform the QC checks. Then step four, you're going to address the findings of the QC checks. And at minimum for the program, and we'll go into this in a little bit more detail later, there are some checks that are automated within the compliance form. So there'll be some flags on the quality control checks tab, and at minimum, you will need to address those. We'll talk about that in a little more detail later on, but either address the issue or provide some justification for the flag. Okay, so step one, check the submittal for completeness. So we have this dashboard tab in the compliance form, and it lists every single tab within the compliance form. And there are locations where the design team and modeler, so the design team and the modeler sign off that those tabs are complete. So when you're checking, okay, is this submittal complete? This is a great way to track that. So has someone from the design team verified that the information that we entered about lighting is correct? Yes, it's marked complete. Has the modeler marked that tab as complete, meaning that modeler is verifying that, yes, I have modeled the lighting per what's been input on these tabs and per the calculated model inputs. So you want to make sure all these are marked as complete on the dashboard. Next, the ERP on the P4P instructions tab. So the ERP, the energy reduction plan, that's the other workbook that you're required to submit for the program. There is a list of all the information that the program requires. So you want to go through that and make sure that your submittal package includes all of those items. So you want to have a folder. Go through that folder and just make sure everything is there. There's also a submittal checklist in the compliance form. And this is based on the reporting requirements of 90.1, which aren't exactly aligned with the P4P program, but more or less they are. So this is a great place as well to check that you've included everything needed in your submittal. And if something is NA, just put NA if it's not required. One item that I just wanted to highlight here is number 10. This is a checklist item for the NFRC certifications for fenestration. And this is something that's often not included in submissions, and it just makes for more review iterations. So if you can have all that up front, mark this as yes, and it'll turn green. That would be great and help speed up the review process. Okay, step two, Establish the QC scope. So the review manual includes a detailed methodology for prioritizing the review. But I just want to let you know that in the quality control checks tab, there are, like I said before, all the checks right here, all the checks in the review manual are listed on this tab. And there are, depending on the impactful uses in terms of total energy consumption and also in terms of savings, this column here, so what we have here, we have the check ID, we've got the QC check, what it is, we've got whether it's included in the review, yes or no, review outcome, and then there's an automated comment right here, okay? So when you look at this tab, after you've filled out the compliance form, you'll see that some of these include in the review checks are automatically marked as yes. So that tells you, oh, okay, this is definitely going to be a check that the reviewer is going to complete. Other checks will have, like I said before, these automated pass-fail outcomes. And so at minimum, we'd like you to address any automated checks that come out to fail. So in this example here, the number of unmet load hours exceeded allowed limits, and there's this automated comment. We would expect that to be addressed or some sort of justification to be provided. In addition to the automated checks, this gives you a basis for doing some additional QC of your model. You can see all the checks that the reviewer would be doing. It's almost like, you know, you've got everything ahead of time because you know what we're going to be checking, so you can check yourself. So on this tab, these columns here include in the review outcome, and this automatically generated review comment. These are only for the reviewers. So these are not for you as the modeler or member of the design team to be adjusting, and they will flag if you do adjust them. So these are for the reviewers only, but you can definitely, they're there for your knowledge in doing your QC. And we'll talk more about areas on the QC tab that are your jurisdiction in a couple minutes. All right, so the nomenclature, so you can see we have these check IDs here, right? So the nomenclature, I just want to explain that briefly for these check IDs, have to do with how the review manual is organized. So the review manual and the quality control checks tab in the compliance form is divided into categories. So we've got general simulation checks, utility rate checks, and then all these other components, renewable energy, well, that's not applicable here, but we've got exterior lighting, interior lighting, plug, process, and other loads. So these are the sections that the review manual is divided into. So each check ID is expressed as an abbreviation of the category. So LE for exterior lighting, for an example. And then the checks are tagged with either a B or a P. So this example down here is building envelope, so BE, check number 8, -P. So -P means it applies to the proposed design. Okay, so just a quick explanation of that nomenclature. This is briefly, I just want to touch on the types of QC checks that are in the review manual and on that quality control checks tab. So number one, we've got checks on the general requirements of Appendix G. So those are things like that the submission does not exceed the number of allowed unmet load hours. And these are always checked on the baseline and proposed. Then we've got a check for whether the systems reported in the compliance form reflect design documents. So for an example, you know, if there's, is the proposed chiller capacity reported in the compliance form, does that align with the capacity in the design documents? Does the efficiency align with that design documents? Does the fan power of the air handling units reported in the compliance form, does that reflect design documents? So that's another type of check we'll be doing as reviewers, and we recommend that when you're QCing your submissions, especially areas that are highly impactful, where you're seeing a lot of savings, where there's a lot of energy consumption associated with that equipment, you do some of your own internal checks just to make sure that what you've entered is aligning with the design documents. Because we all know you get tired, you've been doing it for hours, it's easy to make a mistake. The third check is that specified systems meet mandatory requirements. So you're all very familiar with this one because I'm sure you've seen this comment in your submissions if you've submitted to the program. Lighting controls. So lighting controls are required in 90.1, 2016 in section 9, and they're mandatory requirements. So even if you're pursuing the performance-based path of code compliance, for an example, you still need to meet the mandatory lighting control requirements. So we often have this comment in review documents that, we expect to see mandatory lighting controls in the compliance form because they're required. The fourth is that the baseline systems in the compliance form meet the requirements of Appendix G. So are you modeling the P-tax with 3 watts per CFM? So is that reflected in the compliance form? And honestly, the way the compliance form is set up, most of these items automatically populate. So those are very easy checks to see that what's in the compliance form is consistent with the baseline requirements of Appendix G. But there are a few areas that aren't. For an example, selecting your baseline HVAC system types. That's not automated, so that's something as a reviewer we'd be checking in the compliance form. So that's a great place to have another set of eyes on your submission, checking that you've modeled the correct baseline types, and that's an area where we see a lot of issues with submissions. 5, your simulation inputs reflect the systems and components reported in the compliance form. So this is a real easy one. So basically, do the lighting power densities calculated in the compliance form, do they reflect the simulation tool output reports? And that's an easy comparison to do. Again, these are the kind of checks you really want to do on impactful systems where you're seeing a lot of savings. If you have huge lighting savings in your project, you're going to want to spend some QC attention on lighting just to make sure that your model is reflecting what you think it does. Number 6, that the outputs are consistent with systems and components in the compliance form. So this one would be, are the lighting, as an example, are the lighting equivalent full load hours calculated based on the energy consumption associated with lighting and the lighting power entered in the compliance form? The calculated equivalent full load hours, are they in line with schedules that are approved by the program? So are the equivalent full load hours reasonable? So that would be a check there. And again, these are the kinds of checks you want to do where you're seeing a lot of savings or where there's a lot of energy consumption associated with that end use. And we'll talk a little more about these. We'll do a few demos. And number 7, and this is my favorite check when I'm QCing. Are the modeled end uses consistent with benchmarks? And when I say modeled end uses, I'm talking about energy usage indices. So are the kBTUs per square foot for lighting in the baseline, for an example, consistent with benchmark values? And we'll discuss what those benchmark values are in more detail when we look at the compliance form. But number 7, in terms of QC, these are very powerful checks that can really help improve the quality of your submission before submitting to the program. All right, so this I'll just touch on really briefly, just to entice you to check out the review manual, because it can be really helpful. So what's provided in the review manual for each check? As I said before, there's a check ID, a name that kind of tells you what the check's all about, relevant sections of 90.1 that have to do with the check, the rules, things like that, very helpful. And then a tip. So where can you look in the compliance form to figure out what's relevant? And then it also provides some common mistakes, how to avoid them. So great stuff. It also provides the simulation reports for popular software tools that you can look at to check whether you are complying with this check or whether you need to make an adjustment to the model. And this is just an example of an annotated simulation report that's provided in the review manual. So this is an eQuest report, and it has the check ID, and then it boxes the items that you need to look at on that report to see if you pass or fail the check. So these are very useful. All right, on to step 3, which is perform the QC checks. So we just went over what's in the review manual. So once you've decided, okay, these are my impactful end uses, through experience, we've learned that checking these things really help reduce the number of review iterations. So then you're going to go through and you're going to perform the checks, whether you're doing it yourself as the modeler or whether you're doing it for someone else's model within your organization. So before I talked about how so this is a little screenshot from the quality control checks tab with the check ID here, and then the QC check here, and then whether it's included in the review, and then the review outcome, and then the automatically generated review comment. Okay, and before, remember I said these are off limit to submitters. Well, over here, this is your jurisdiction. So anything that's these peach colored cells, that's where the submitter is allowed to write. So you can use that as a way to keep notes on the different checks as you do them internally. And then that's a place to communicate with the reviewer as well. So for an example, someone from your organization could do some checks, put a few notes in those columns, and then the modeler could go and look at their notes and address the items. Step 4, address the findings. So again, this is your jurisdiction as the modeler or design team member for addressing the findings. So either what's going to happen is you're going to see the flag. So this is unmet load hours exceed allowed limits. It automatically went to fail. Tells you what's, the reason that you're getting the fail. And then you would adjust the model to address it. If you can't, if there's some sort of justification for a fail outcome, you would describe that right here. So in this example, this particular project was failing the unmet load hours, and the response was that it only applies to a small 50 square foot storage room. And so the review team would then discuss whether they're willing to allow that. All right, so now we're going to drop into the compliance form itself to take a look at some of these inputs and fields and tabs we've been discussing. Okay, so this is the instructions tab of the compliance form. Because we went into detail in the previous training about the compliance form, we're just going to really focus now on the QC related tabs. So I'll just do a little drive-by as I'm going to the QC related tabs to show you general information. So if you're doing QC on a project in your organization and you know nothing about the project, check out general information. It'll tell you size of the project, the square footage, the building area types. This will give you a sense of the type of project. As we talked about in the PowerPoint, there's the dashboard, and this helps you check the submittal for completeness. Did I remember? Did I remember to review the lighting tab? Oh yeah, I marked it as complete. Great, I did. Check. So this is a great way of tracking completeness. So then we go all the way to the right and take a look at the submittal checklist. And this is also something that we talked about in a bit of detail in the PowerPoint. So I'll just do a drive-by here. So again, this is very helpful in making sure that you provide the information to really help the review team understand the submittal, understand if sometimes something comes up and maybe you had to use a workaround or something. You want to make sure that all that is very clear to the reviewer, and providing the information in this checklist is a way to do that. Okay, so next let's take a look at the energy performance summary tab. For me, this is my favorite tab. Even when I have to fill out like some other tool for an incentive program, I still use the compliance form just for this tab because I find this very useful. So the stuff that's on this tab is the gist of it is that it compares the energy performance of the proposed and the baseline design to benchmarks. So we'll come back up to the top. So let's go down to these tables below. So just every tab has a table of contents, so you can see all the tables and sections on the tab. So right now we're jumping down to the energy performance benchmarks section. And here we can see our proposed design and our baseline design benchmarks. And this is essentially telling you what is my model being compared with. So in the case of the proposed design, for this example, my model is being compared with the PNNL prototype model for a weighted average of high-rise apartments and standalone retail. And that's because for this sample that we're doing here, it's a multifamily project with retail on the ground floor. So these are the appropriate PNNL models to compare the proposed design to. Okay, so actually in the case of P4P, we would probably want to compare with the 2019 version of the PNNL prototype models. And the PNNL prototype models are essentially just models created to serve as representative of that version of 90.1. Okay, so they're good, and they're created by climate zone. So that you would be comparing this building type, so weighted average, for the climate zone that your project is associated with. For the baseline, because with 90.1 2016 Appendix G, the baseline model is more or less set at 90.1 2004. A great source or a great benchmark is the PNNL prototype models for 90.1 2004. So if we compare our EUIs to those model results, that's a really good way of telling us if we have a potential issue. So let's scroll down to the table 7 compares the baseline to the benchmark. So here I have comparisons across different metrics: site energy, source energy, energy cost, greenhouse gases. And so you can look at the different metrics. I typically tend to look at site energy. It tells you in your percent difference from your baseline model and the benchmark. It tells you the percent difference. So if there's one that's quite high, you might want to dig into that, or it's strongly recommended you dig into that end use to see what's going on, see why your model differs so much. There might be a very good explanation. For example, the PNNL prototype model could have different HVAC system types than your baseline model, and that could lead to the difference. but it's a very good way of identifying areas where there are issues. And there are charts for helping you get a visual understanding of how your model, and you can toggle between different types of charts, how your model compares. So you could do that for both the baseline and the proposed. And then up here, there's a section in table 2, 3, and 4 to help you assess your most impactful end uses. So P4P compliance is determined in units of source energy and cost. So you really care most about these columns. So table 2 tells you end uses with the highest contribution towards energy use in the proposed. Table 2 tells you the highest contribution towards energy use of the baseline. And table 4 tells you the end uses with the highest savings. So typically I focus on the top 3 in each of these categories. If you're trying to triage your QC effort, you want to focus on most impactful end uses where trade-offs are allowed. So this is a really good way to see that visually. Also, it could tip you off to an issue. For an example, if you're seeing that, let's say space heating is one of your top end uses for savings, and you're thinking, wait, I don't really have heating measures. I don't really have space heating measures. I could tip you off on maybe there's an issue somewhere. So I love this tab for QC. I find it very helpful. Okay, so then the quality control checks tab itself. So at the top here is just a table for tracking revisions. So as the submitter, once you've addressed all the automated flags that we talked about before, you're going to put the date in here. You're going to put in your name, and then you're going to submit it to the program. This table here tracks the flags and responses by different categories, which you can jump down to by clicking on these hyperlinks. So this submission is not complete. It's not ready to be submitted to the program, because I can see that for Simulation General, for an example, there are 6 automated flags and 0 responses. So the QC effort is not complete on this one. And once either these are all addressed or there's at least a response, each of these, this will turn yellow. So red means you're not ready to submit because your QC flags have not been addressed. So this should all be yellow. Yellow, I mean, or green would be wonderful, but we don't live in a perfect world. So these should all be at least yellow before you submit. There's a unique feature for communicating on this tab. If you double click, you get a communication box to make, sometimes it's hard to type in Excel, so this makes it a bit easier. You hit close, information goes in, you click on it again, it's still there. You can keep it going, you can go back and forth, forever. So then if I double click it, it's still there. That's just to help. Sometimes it's hard in Excel to type messages, so that's a little helper. There are instructions, so please check out these instructions. So here's the color legend. So this blue is for the submittal reviewer. So anything that's this like teal blue color is not for the modeling or the design team. So don't change those things. You can toggle to see all checks. You could also just see baseline checks or proposed only checks. That's a way to just organize yourself when you're performing your QC. As I said, the QC tab is divided into these sections. So right now, here's the Simulation General section. Zoom in a little bit, make it easier to see. And there are helper summary tables in each section with hyperlinks to the tabs where that information came from. So you can jump to that tab to make adjustments if something is incorrect. And then we saw this in the compliance form, but then we have our columns here where we've got our check ID, we've got our QC check, whether it's included in the review, and many of these will be automated. The reviewer will likely add text to include in the review once you submit this to them. You can at least see the defaults that are very likely to be included. The review outcome, again, these are all the teal is reviewer only. The automatic comment generated by the compliance form. And then here's your spot for entering your justification for a flag, internal communications if you'd like, and it has that same feature with the communication box. Okay, and then for each review check, there is some information to help you. So if you click on REF here, you get a pop-up that will tell you the relevant 90.1 references, if there are software references, so if there's a particular report that you should check out, it also will tell you that as well. So you don't necessarily have to open the review manual if all you're looking for is that information. So there's our automated flag. There's a few of them here. We'll go over these once we do some review check demonstrations in a few minutes. Let's see here. There's a freeze panes feature here to just help, so you can more easily scroll. Click it again to turn it off. And there are various helper tables, as I said on here, help with triaging the QC process. So for an example, and we'll see this in a few minutes too, this is the interior lighting section. That's where I am, and there are these helper tables that rank. So here are 3 columns: space types, thermal blocks, and fixture types, all ranked by the total wattage. So this can help you triage. So for an example, you could see under fixture types, fixture E by far has the most wattage associated with it. So you could say to yourself, all right, I'm going to at least check fixture E, make sure I entered that correctly. So it's a way to fine tune your quality control process. So there are those helper tables. Okay, I just want to make sure I covered everything here. And if you do override something, it will alert the program. An automated message will be sent out. No, I'm just joking, but it will flag if you override it. Okay, so I'll keep going so we can make sure we get to all the tips and common mistakes, because that's probably what everybody's here for. So this is just some demo. This is a demo of some of those QC checks that I was talking about, just to help the concept sink in a little bit. And this first one is a simulation general check. So you can see that right here, because it's an SG check. And these check IDs are great because you can open the review manual, and all you have to do is a Control F, type in that check, and you can go straight to it in the review manual to get more information to help you troubleshoot, to understand what the check is all about, to understand the sections of 90.1 relevant to the check. So this first check I'm going to demo is the number of unmet load hours reported in the compliance form does not exceed prescribed limits. So these are some review tips here from the review manual. So the review manual tells you that check out table 1 on the compliance calculations tab, because this is where that information is reported. And then it explains why it's a problem that unmet load hours exceed allowed limits. So basically, it's not an allowed trade-off. So in our example here, we can see that there are 642 unmet load hours in the proposed, and that means that there are 642 hours where less heating and cooling is being provided, or potentially being provided in the proposed model. The space temperatures are in the case of heating are lower, or the space temperatures in the case of cooling are higher than the baseline, because the schedules need to remain constant between the two models. And that's not an allowed trade-off. You can't get credit for having lower, for reducing occupant comfort, in the proposed model. So that's why this one is very important. And this check is automated in the compliance form. And this is also from the review manual, and there's a lot of text here, but I did want to include this because this is where, as a modeler, the review manual can be extremely helpful because it provides some common reasons for unmet load hours. So a very common typical reason is that thermostat schedules do not align with the HVAC system schedules, occupant schedules, miscellaneous equipment schedules. So bottom line, you just have schedules that are out of line. So for an example, your thermostat schedule might be resulting in a call for heating let's say at midnight. And it's saying, I can't meet set point, but your fan schedule is set such that your fan's not allowed to turn on. Well, if that's the case, you're going to get unmet load hours. So that's one area to look at if you are having an unmet load hours problem, is schedule alignment. The next is internal gains or occupant densities, or even like outside air ventilation rates that are just out of range or unreasonable. So maybe in a couple zones you made a typo and typed in 10 watts per square foot instead of 1. And so, when you do your proposed design, the equipment is just not sized to meet the loads because the internal gains are just so far out of the expected range based on the equipment sizing. So issues like that. Another major one is that the operation and controls associated with primary or secondary heating or cooling equipment, so like pumps, coils, boilers, is out of alignment with heating and cooling requirements of the building. So this is an example where the coil in your air handling unit needs some hot water, but your pump schedule is set up such that your pump can't operate. So that unit cannot get hot water, so then you've got unmet load hours. And then the final, so after you've ruled all these other things out and you've checked the model, run hourly reports, talk to the design team. Maybe you had different assumptions in terms when maybe they use different assumptions for sizing the equipment, and maybe the equipment is not adequately. So that would be the fourth. So this is the kind of stuff that's in the review manual that can help you. So this is a screenshot that we actually saw this from the quality control checks tab, showing that this is an automated check. And so in our case here, I had mentioned before, this only applies to a small 50 square foot storage room. So you would supply that explanation, and the review team would consider that, and they would consider accepting it. I'm not going to say for sure whether they would or wouldn't, but that's where you would provide your justification. And actually the review manual will provide some extenuating circumstances where some jurisdictions may accept a failed check. So for unmet load hours, the storage room is mentioned here. It only applies to a very small area of the building that's not really occupied. So it's not impactful. Okay, so next we've got SG, so Simulation General 11 Proposed Model Check, which is to check that the interior lighting energy use of the proposed design is consistent with the selected benchmark. So the difference is less than the set threshold. So like I said before, I love these checks. So review tip in the review manual, which we show here, is just question it. If the EUI is outside the limit within the compliance form, and those are located, and I think we have a screenshot of it. Yeah, we do. Next. So there are limits in the compliance form where this will flag if the benchmark differs by more than those limits. Question it. And so when you do see that, for an example, the proposed lighting EUI is significantly different from the proposed EUI for the benchmark, it might be that the modeled wattage is too low or too high, runtime hours are too low or too high. maybe the occupancy sensors, there was a mistake in modeling them, and the savings are showing as too high. So these common mistakes are in the review manual to help you again with troubleshooting the issue. And this is another automated check. So this is automatically performed. And before we looked at that energy performance summary tab, and this is a screenshot of table 6, which compares the proposed EUIs to the benchmark. And I've just selected the interior lighting row to show you that here the percent difference is 54.1%. This is why we're getting a flag here, an automated failed check, because over on the right here, in this table, these are the thresholds, so that you know, for full transparency, these are the thresholds where you'll see a flag. So to explain this, you see 50%, and it's kind of hard to see because I have an X over it, but you see 50% in both of these columns. So if the difference is more than 50% between the proposed EUI and the benchmark EUI, you're going to get a fail. It's going to flag. And these are not for you to adjust. These are set by the program. Right now, they're just defaults in the DOE compliance form, to be adjusted potentially in the future. But right now, they're set at 50%. So you do get a flag for this. So in our example here, we got a flag. Our proposed EUI is 54.1% different than the benchmark. And so it doesn't mean that it's wrong, but all it does is it tells us we really need to check this. So we need to make sure that our entries align with design documents, and we need to make sure that our actually modeled lighting power densities align with the compliance form. And then we need to check our schedules. Did we maybe mess up the assignment of the schedules? Maybe we assigned a 24/7 schedule by accident or something, and we're seeing a lot of savings. Although then we wouldn't have a low proposed EUI, but you know what I'm getting at. It could be a schedule issue. So if you check everything looks great, then in your peach column, you would just provide an explanation. We have all high efficacy, state-of-the-art, beautiful LEDs, and our project is just doing great. So, no correction made. Okay, so our next one, and this is a common mistake. So this is another lighting check, and I'm trying to give you a flavor of all the different types of checks that are in the review manual, because remember we talked about those types of checks. So this is a check that the proposed lighting power density to be modeled where lighting is not specified or partially specified is established correctly in the compliance form. So this is a check to see whether or not the compliance form is following the rules of 90.1 for determining the base, the proposed LPDs. So this check is especially relevant to hotels, motels, multifamily, core and shell projects where either lighting is not yet designed, like core and shell, or where there are areas where the design intent is for these spaces or areas to be supplemented with plug-in fixtures. So it's very common, especially in multifamily, for the designers to design hardwired fixtures for the bathrooms, the kitchens, and maybe they put one in the hallway. And then the assumption is that plug-in fixtures will be used by the occupants to provide the remainder of the needed lighting. So these are some review tips in the review manual. And the main tip here is to check the interior lighting counts tab, table 1 column, for floor area where lighting is not specified. So I'm going to show you this. So this is the interior lighting counts tab. This is the column. So say you're reviewing your colleague's project and it's multifamily, and you check this column on the interior lighting counts tab that the review manual told you to, and you see a 0. that would be, you would say to yourself, okay, I need to open up the design documents and I need to check this because this is it's possible, but it's unexpected for multifamily. So then here we've got a screenshot of the actual design documents, and we can clearly see that this area here in yellow, which is the living room, so these, the objects you see here are just receptacles. There's no lighting fixtures specified here. So because of that, we would expect this to be a non-zero number. So this would be something that needs to be addressed in the submittal, because area where proposed lighting is not specified was not entered correctly or at all in the compliance form. So that would need to be corrected. This is not an automated check, but it's one that I strongly recommend since it is such a common issue that we see in submittals. All right, our next one is a check. This is a baseline check, whether the baseline interior lighting wattage entered in the simulation tool reflects the values reported in the compliance form. So this is our tips from the review manual, telling us what to do, basically. And it shows us what reports we want to look at within our simulation tools in order to compare lighting power density calculated and shown in the compliance form to what's been modeled. And so this tells us the tables to look at in the compliance form. And then this tells us the simulation reports to look at, okay? And so let's do that. First, I'm going to, so this number 2 here explains where to look. It also explains and encourages the QC person or reviewer to look at the quality control checks tab to come up with a sampling plan. Because you could have hundreds of thermal blocks in your model. You're not going to check every single one for the LPD. So there, like I said before, when we were in the compliance form, there are some helper tables to help you come up with a sampling plan to check your most impactful fixtures, thermal blocks, and spaces. So this is a screenshot of a table. And here I could see my top 10 thermal blocks in terms of total wattage are shown here. So these would be the thermal blocks that we want to focus on when we look at the lighting power densities in table 2 on the interior lighting model inputs tab in the compliance form. When we look at those lighting power densities, and we compare them to the simulation reports, these here are the thermal blocks that we want to focus on. Okay, so our example today, I'm going to show you an example. We're going to look at corridor 2. It's ranked number 4 on our list, so it's pretty important. But I just wanted to show you, what does this look like? So here is table 2 in the compliance form. This is where our lighting power densities are calculated by thermal block, and this is within the compliance form. So these are our baseline lighting power densities. So I can see here, this is core 2. So we saw that here, core 2. So here I've got my 0.52 calculated lighting power density for the baseline. Over here, I've got my LVB report from the simulation tool. And these are all the thermal blocks, all the names. So I find my core 2. I've decided I want to check, and I look at the lighting power density, and I could see it matches. So it's 0.52. So this is great. I've modeled it correctly. And actually, it can be pretty easy to check these depending on the simulation tool you're using. For eQuest, it can be pretty easy depending on the order and the naming conventions. In this example, my compliance form thermal blocks are actually in the same order as my output report. So I can very easily see, wow, I did a good job in this model because they're all matching. So this is a really great check to to reduce review iterations, because you can be confident that you're modeling what you intended to model. And obviously this is not automated, so this would be, if lighting is highly impactful in your project, this is a good QC check to do before submitting. And our last example check, so this one is checking that the model outputs, model results are in line with expectations. And it's to check that modeled interior lighting runtime hours of the baseline design are realistic. So these are our review tips from the review manual. And it basically tells us how to calculate equivalent full load hours, which is essentially the sum of the hourly scheduled fractions for the entire year. So it gives us an equation of how to calculate that. So we take our simulated annual lighting energy use, kWh, and we divide by our total lighting wattage, which is presented in table 1 on the lighting model inputs tab in the compliance form. It tells us where to get the information we need. And then it tells us that on the quality control checks tab, the compliance form tells us typical lighting equivalent full load hours for our building type. So this check is automated in the compliance form. It basically confirms that the equivalent full load hours do not significantly exceed typical. And it looks like this. So this is the table where on the quality control checks tab where this is performed. And so it's calculating the baseline effective full load hours here automatically. And then it shows the weighted average equivalent full load hours of typical here. And we can see, we can do a little percent difference, and we can see our model is only 2.3% different. So no flag, that's close enough. And so we're happy, and we can move on. So that includes I just wanted to give you a flavor of the QC checks, how to conduct them, what the process is like, and encourage you to check out the review manual, because I think it can help improve just the quality of submissions overall, like even regardless of doing QC checks, but can also just help identify issues before you submit. So the last 15 minutes before we stop for questions, we'll go over some common issues and just some tips we have after doing a lot of reviews for the program that we would like to share with everyone. So this seems simple, right? Our first tip is to use the notes field. So the compliance form under each table, each section has a notes field, and simply just putting a note. If you know something is going, like a reviewer is going to question it. So in the example I'm showing here, the modeler entered the building areas from the design documents, and the modeler knows that what the reviewer is going to see in the model is different. And so they decided to include an explanation in the notes section that the modeled square footage differs from design documents because the square footage, the design documents only includes the inside perimeter of exterior walls, and the modeled square footage includes exterior walls. So generally for the program, we expect the design document square footage and the modeled square footage to be within 10%. And if you are, let's say, like 8% different or something, throw a note in here. Avoid a comment. It also just shows that you're doing your due diligence and that you're really thinking deeply about the model and the inputs. So I think it's really good practice and highly recommended. It also helps you keep track of what you've done, assumptions you've made, things like that. So we've already talked about EUIs, but I can't emphasize EUIs as being, comparing your modeled EUIs to benchmarks, how effective that can be to identify issues within the model. And just, this is a little late in the game, but energy usage indices are total annual building KBTU consumption divided by the gross square footage. And we already went over how the compliance form does this automatically for you on the energy performance summary tab. But the thing that I wanted to point out here is just that, let's say you do see a big difference in your baseline. Let's say you're comparing your baseline to the PNNL prototype 2004 model, and your ventilation energy, your fan energy is just way higher. Let's say, say it's 100% higher, it's double. And you're just like, I don't know why. I've checked my model inputs. I just wanted to share with you that there are these scorecards, and you can get this link when you download the presentation afterwards. There are these great scorecards that are very simple, and you can download them from the energycodes.gov website. And here's a little excerpt from them for a large office. They're Excel files, and in a very neat, easy to read, organized fashion, it shows you the assumptions in those prototype models. So here's an example for a large office. I can quickly see, okay, so in the prototype model, it was VAV systems, water source DX cooling, and you don't need to do it like a research project on this, but if you're like, I've checked my model inputs and my EUI is just really high, I know the reviewers are not going to like this, download the scorecard real quick and check out the assumptions that went into the PNNL model. Like I said, they're easy to identify, and it might just tip you off. For an example, you might say, oh, you know why I've got constant volume systems in my baseline, and I can see that the prototype has VAV systems. So, okay, that explains why my fan power is a little higher. I'm going to drop that note, on the quality control checks tab to avoid, a back and forth with the reviewer. So again, you don't need to do like a research project, but if you're struggling, we wanted to point out, you can check out these scorecards that will give you some more information on the prototypes. Next is, and we went over this with the lighting QC check, but use output reports to make sure that you're modeling what you think you're modeling. One awesome output report that I personally just love is this HVAC summary report CSV file, and this applies to eQuest. Sorry if you use another software. If you have any tips for other software, let us know. But afterwards, you can download this presentation to see exactly how to do this. If you open your INI file and you just add this line here, eQuest will generate an HVA summary report CSV file. And it looks like this, in that you get a CSV file of all your modeled systems. So it basically takes the SVA reports, if you're familiar with those, and puts them in a CSV format. And for doing reviews, for QCing your models, for getting the capacities and CFMs for the baseline, these are great. You can just use Excel formulas to quickly sum for an example, your fan power, like right here. It's a great QC check. And honestly, when you're conducting reviews as well, this is what we can easily look at to see, okay, what are you modeling for your cooling efficiency? What's your heating capacity, cooling capacity? What fan power is being modeled? CFM. And it just makes it so easy to have it all in this format. So I just wanted to share that in case other people don't know about this report, because it really saves a lot of time and helps with the QC process. But a little thing to watch out for. The values in this report don't account for floor multipliers, so you'll just need to add that if you have floor multipliers. So for an example, if you had a floor multiplier that applies to the system 10, each of these would be multiplied by 10, like the fan power or the CFM would be multiplied by 10. Next, okay, so this is a common issue. So In 19.1, regulated and unregulated loads are treated differently in the performance outcome calculation, and sometimes you need to manually separate them. So this needs to be done for the program, both in the ERP on the P4P measure simulation tab. So you could see here, and a common mistake is often in eQuest, elevators are lumped with miscellaneous equipment. So it comes out of the model, plug and process roads are lumped with elevators, and they need to be separated out because plug and process is unregulated and elevators are regulated. So you're going to need to make a manual adjustment to separate them on this tab so that the compliance calculation is performed correctly. And this is a very common issue for the program. This also needs to be done in Table 2 on the Compliance Calc tab in the compliance form as well, so you can see how you're doing in the compliance form in terms of performance, and so it's calculated correctly there. This is also an issue. It's a common issue for elevators. It's also a common issue for refrigeration equipment. Many submitters forget that, like, for example, there are regulated display cases and then unregulated walk-ins, for an example, and submitters sometimes forget to separate them into, like, one's regulated, one's unregulated. So just make sure to do that when you submit. Next, related, don't forget about elevators or any other building loads for that matter. All loads need to be captured in the model, but it's very, very common for submitters to forget about elevators. And elevators, not only are they regulated loads, they have specific modeling rules in Appendix G, which you can see a screenshot of here. And these rules are captured in Table 6A in the compliance form on the plug, process, and other loads tab. So all you have to do is enter your information, and the compliance form will automatically calculate your model inputs for the baseline elevators. So it's there for you at your fingertips, but don't forget about them. All right, here is another. This is a very, very common issue. So there's no extra fan power allowance in the baseline for exhaust fan. So the common issue is essentially that what happens is the entire baseline fan power allowance is applied to the HVAC system fans serving a zone. So for an example, a submitter will model their dwelling unit P-tax as 3 watts per CFM per the rules of Appendix G, which is correct. But then they'll also model the exhaust fans and include kW per CFM or fan power for those exhaust fans in the baseline. And that's not allowed. So you've got your 3 watts per CFM allowance, and you don't get anything extra for those exhaust fans. And we have an example similar to what I just described to illustrate across a few different scenarios. So in our example building here, we've got apartments, corridors, trash rooms, and a boiler room, okay? So the proposed design configuration is such that apartments are served with VRF heat pumps that provide heating and cooling. And then each apartment is also served by a continuously running rooftop bathroom and kitchen exhaust fans. So continuous kitchen exhaust fans serve apartments. Corridors are served by 100% outdoor air rooftop units that provide outside air, heating, and cooling. Then there are trash rooms on each floor in which a rooftop exhaust fan serves them, and then where makeup air is provided from the corridor. So essentially, there's like a transfer grill, and air is being transferred through that grill as makeup air to the trash rooms. And then we've got a boiler room where there is an exhaust fan serving that room. The room is unconditioned. Makeup air is supplied from the outdoors. It's all unconditioned. So the question is, what is the baseline fan power allowance for each of these unique thermal blocks? All right, here they are. So for apartments, PTAC is our baseline system type, and we have our allowance of 0.3 watts per square foot, like I said before, with no additional fan power allowance for the kitchen and bathroom exhaust fans. So you can include the CFM, but set that kW per CFM equal to 0 on the baseline. Then we've got corridors. So corridors, they're under 20,000 square feet, so their baseline is also PTAC, and their allowance is 0.3 watts per square feet. So that the PTAC allowance, 0.3 watts per square feet. We've got the trash rooms. So the trash rooms, there's no additional fan power allowance for those exhaust fans because they're actually part of the corridor thermal block, because they're being served through that transfer grill by air provided by the corridor HVAC system. So they essentially fall into the corridor thermal block, so they're covered by that PTAC 0.3 watts per CFM allowance. So you don't get anything additional for those trash room exhaust fans. And then the boiler room, it's not conditioned, and makeup air is unconditioned, so there's no baseline or proposed HVAC system. So you would model it the same in the baseline and proposed, with the exception that the fan efficiency, the fan motor efficiency would be modeled with the efficiency per Appendix G in the baseline, and then with the proposed design actual fan efficiency. So you can get if you have a high efficiency fan, you can get a little bit of credit there. All right, moving right along. Here's another common issue, and that's with determining the baseline HVAC systems. So just essentially often submissions have the incorrect baseline HVAC systems modeled. And so we want to go over some steps for determining how to come up with your baseline system types. So the first step is to identify all building area types listed in table 3.1.1-3, which is this table shown here. So these are your building types: residential, public assembly, heated only, retail, other non-residential. So those are your building types. So identifying all these building types and the conditioned square footage associated with each. Then in step 2, the building type with the largest square footage is the predominant building type. So step 2, determine your predominant building type based on whichever one of those has the largest square footage. Step 3, all other building types identified in step 1 that are less than 20,000 square feet get absorbed into the predominant building type that you decided in step 2, with the area adjusted accordingly. So you might be increasing the area of your predominant building type to absorb other building types that are less than 20,000 square feet. Step 4, determine the HVAC system type for the predominant building type in conjunction with the floor area established in step 3. In step 5, determine the remaining baseline HVAC system types for non-predominant building types identified in 1, where the floor area was greater than 20,000 square feet. And like I said, you can download this PowerPoint and get these steps for when you do your submittals. So let's do an example. So we have a 2-story building. 150,000 square feet is retail, 15,000 is office space, 6,000 square feet is daycare. So step 1, we need to determine our conditioned square footage associated with the different building types. So we look at this table and we see, okay, so we have 150,000 square feet of retail. And then you ask yourself, okay, what do I do with the office and daycare? Well, office and daycare both fall into the other non-residential category. They're not public assembly, it's not residential, so it's other non-residential. So you sum these together to get the total. So my total is 21,000 square feet of other non-residential. So I've summed my square footages. Step 2, now I need to determine my predominant building type. So this is an easy one. It's obviously retail because it's 150,000 square feet compared to 21. Step 3, this is where if you did have building types less than 20,000 square feet, you would basically get rid of them, forget about them, and take their square footage and add them to the predominant building type. So if I had a 10,000 square foot public assembly area, then I would just add that to retail and it would become 160,000 square feet. Step 4, determine the HVAC system type for predominant building type. So in the case, I have retail, and it's two floors or fewer. As we said, it's a 2-story building, and our climate zone is 4A. So we can pretty easily see that it's system 3, package single zone AC. And then step 5, we do the same thing for our non-predominant building type. So we look at the table and we have 21,000 square feet of other non-residential. So we look at the climate zone 4A column. So other non-residential and 3 floors or fewer. Okay, check. We have 2 floors and less than 25,000 square feet. Check. This is 21,000 square feet. So we land on system 3, package single zone AC. So that would be the process for our example. So this is a lot to take in. This presentation is packed with information. So I encourage you to download this and follow these steps when you're doing this for your projects. All right, number 8, modeling. I'm just going to touch on this quick because I see the clock moving along quickly. Number 8, modeling non-compliant lighting. So in the partner guidelines, there are specific rules regarding how to model lighting that is not Energy Star rated or on the Design Lights Consortium qualified product. So check out the partner guidelines because this is a common issue. There are specific rules for when the lighting does not comply. Basically, it requires that you figure out the area where lighting is non-compliant, and then you calculate the watts per square foot. And if that watts per square foot is greater than the prescriptive value, table 9.6.1, you just model it as is. So for the compliance form, if that was the case, if your watts per square foot was greater than the prescriptive value for the area served by non-compliant lighting, just enter it as usual in the compliance form. However, if you calculate it and you find that your watts per square foot is less than the value in table 9.6.1, the prescriptive value, then you can utilize this area where proposed lighting is not specified in the compliance form and enter that area there, and do not enter the fixtures in the compliance form. And it'll essentially just apply the prescriptive value to that area for you. And then add a note in the additional notes section, just explaining why you entered that there. And there's a little example note here that you can check out after the presentation, just to let the reviewer know why you entered area where lighting is not specified. And then we just wanted to let you know that for modeling and regulated refrigeration, there is a tool on the portal that helps you establish model inputs for regulated refrigeration. There's an accompanying tech tip with instructions for how to take these inputs and enter them in eQuest. So the tip here is to just check that out, because it can be helpful with, it's a little complicated with the HR ratings and all that. So there is a tool for helping with that on the P4P portal. And then I think this is the second to last tip. Keep your references handy. So here's just a slide with some references. So I think it helps a lot when you're doing a model or reviewing a submission, have all of these references open. And even if you're 90% sure about something, I would just check, because there's so much that goes into these projects that it can be worth just a glance at the relevant section just to make sure you're doing it right. So here are just some recommended references to have at your fingertips when you're doing these models. And lastly, it's just to utilize hourly reports. Here I just have an example where the submitter thought that their unit was operating as variable air volume and providing minimum outside air rates during occupied hours. But running a quick hourly report, you could see that the unit is actually cycling off, because for most hours in a 24-hour period, it's supplying absolutely 0 CFM to the space. And so if you're ever like, oh, I'm trying something new, or I'm not sure, just run a quick hourly report. They're so valuable in troubleshooting and identifying issues. And again, that will really help reduce review iterations. All right, well, thank you so much for your attention. I hope some of this was helpful. Please download the PowerPoint so that you can properly digest all of the material, and happy to hear any questions you may have. Thank you.
Okay, great. So one question that was posted a minute ago, where can we find the review manual? Looking at quick internet search, I only see a draft version. And no, so this document, this is the ASHRAE review manual user.
It is, yeah. So so basically the posted version is still labeled draft. So that would be the correct version to use. There'll be an update in the future, but for now, yes, that the draft version is the correct version. So you found it.
Yep, and it's not posted on the partner portal, although I suppose we can include a link. That would probably be helpful.
Yeah, there's one in the, I'm just looking for the slide. So there's a link in here. Okay, here it is. So if you go to this slide, so when you download the PowerPoint, this here is a hyperlink. So so if you click on that, it'll take you to where you can download it.
Great. Okay, so while everyone is still potentially thinking of a question, or maybe not, I just wanted to let you know that a recording of this webinar will be posted to the New Jersey's Clean Energy Learning Center website. It's a sister website to the Clean Energy Program website, where we keep a lot of our webinars and trainings and things like that. So I'll send that around once it's posted. I'll also include a copy of the slides for the group, as Christina mentioned, so you can review anything in particular and maybe follow up with any questions you might have. And then finally, we have our final and fourth webinar in the series of webinars is currently scheduled for May 11th. So we're going to confirm that date and send out a registration link probably within the next week for that event. And that final webinar will focus on integrated design, which correlates to our pre-design bonus incentive in the P4P program, and also the ASHRAE BQ compliance path. That was briefly mentioned at the beginning of the presentation, but the vast majority of our projects follow the ASHRAE Appendix G path, and so this will focus a little bit on the other option, and perhaps that might be of value to someone that may have wanted to try it but wasn't sure what that involved. So we'll be able to focus on that a little bit more. So that's all I wanted to mention. If you have any questions after the fact, please feel free to reach out to me. Like I said, I'll be in touch with updates on the posting of the recording and the slides. And so keep an eye out for that. And hopefully we'll see some or all of you at our fourth training in May. Thank you very much. And I'll let everyone get back to their day. Thank you, Christina.
Thanks, everyone.